Good morning. Welcome to this course on exochemistry in ARPIT 2019 chemistry. We have seen in the last class the point groups up to, starting from triclinic to monoclinic 3, orthorhombic 3, tetragonal 7, trigonal 7, but 2 taken to hexagonal only 5. Then hexagonal 7, totally 27. Now the cubic. In cubic, A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90. This is called isometric. Sir, camera. Now this is a cubic system. We can take this as say A and B and this is C. That is A, B and C. Whichever you take it, you got a square base. Here, when these three angles like A is perpendicular to BC plane, B is perpendicular to AC plane, C is perpendicular to AB plane. So at this corner you can see this is threefold built in, is getting generated. So we have to consider this threefold in the beginning. So when you take it that way, in cubic, this is a projection. We should consider this threefold at the corner. Now it is 2, 3. The twofold is acting along here or here or here or this is the one. So when I rotate it here, I get a circle. Then when you rotate it here, you get a dot. Then again a circle. Then the next one is 2 bar 3. So we first start with this 3. Now you rotate here and invert. When you rotate it here, you get a circle. When you invert it, again you get a dot. Then you continue this one. Then you end up here. Then further, when you rotate and invert, you will end up this way. Okay. So now we should not use this twofold. We should use this twofold or this twofold. Now again we can repeat a threefold. I rotate this way, rotate and invert. I get it here. Then further you rotate here and invert, you get a circle. Then you rotate and invert, you get a dot. Then continue, so you end up this way. This is 2 bar 3. The next one is 2 by M3. Now this is our 2, 3. This is 2, 3. When you put a mirror here, now either I can use a mirror here or a mirror here. So when you reflect it here, it comes here. So now we can see that 2 bar 3 is equal to 2 by m3. So this is cancelled. This is the same thing, so it gets cancelled. Then comes 2m3. This is 2, 3. And I put a mirror here, just this mirror, you get the same thing. Sorry. Okay, so you get this 2, 3. Then you put a mirror here. Now we'll go to this 3m. In trigonal, this is 3. Then the mirror is coming here or here or here. That is to say, this is a mirror. This is a mirror. This is a mirror. So what happens? This gets reflected. So same thing here. The mirror is operating here. So you get this one here. So you get a circle. Now the next one is 4 bar 3m. Now we know this is 3m. That is here, m3. Now we can see that this is a 4 bar. You rotate by 90, then invert, you get this one. So this is 4 bar M3. Then comes, now we can see that 2M3 is equal to 4 bar M3. So this is cancelled. Next is 4, 2, 2. So here is your two, 3. Now the twofold is operated. Now we can go to this 3, 2 in trigonal. This this is the 3. When you operate a twofold here, you get a circle here. So the same thing is operated here. So this is nothing but 4, 3. Then the last one is 4 by m, 3m. So now already we have seen that is 3m. Apply a mirror. This is a 4-fold. A mirror is applied. So 4 by m, 3m. So there are totally 5 point groups in cubic. So try to mono 3, ortho 3, tetra 7, trigonal 5, hexagonal 7, cubic 5. Totally 32 point groups. So far we have seen in G groups rotation like 2, 3, 4 and 6, and refraction symmetries only. Further, the translation symmetry also comes into picture for packing. Seven systems, 32 point groups give rise to 230 space group. But not equally distributed. When we consider the rotation along with the translation symmetry. We end up in getting a screw. Depending upon two-fold plus half translation to one screw. Three-fold plus one-third translation 3/1 screw. Three-fold plus 2/3 translation 3/2. Now to remember, 3/1 and 3/2 are the same in opposite direction. Then you get 4-fold plus 1/4 gives to 4/1. 2/4 gives to 4/2. 3/4 gives 4/3. Again 4/1 and 4/3 are the same in the opposite direction. Same way, six-fold plus 1/6 gives to 6/1. 2/6 gives to 6/2. 3/6 6/3. 4/6 gives 6/4. 5/6 gives 6/5. Now 6/2 and 6/4 same in the opposite direction. Similarly, 6/1 and 6/5 same in the opposite direction. When we consider reflection followed by translation, it leads to glide. When we consider A axis perpendicular to BC plane, BC plane acts as a mirror plane. Now let us take this is BC plane. Perpendicular to A axis. Now this is the original. Here in space group the convention is originally is as a circle, while in point groups we consider dot and circle. So when this gets reflected, you get the image. This is the image. Now this image is getting shifted by half unit. When you take this is 0 to 1 unit, when this comes here, now it is here. So this means when it is moving along this axis perpendicular to A axis. Now let us say this way. This is my 0, this is my B, this is my C, perpendicular to A axis. And this BC plane is the mirror plane. The motif which is here gets reflected and it comes here this way. That is this and this superimposed. So to show that, we use this way. That is, this is moving here this way. So this comma and minus shows it is below the plane. Open circle is positive. Now this moves here, so you get it here. So this is now BC plane is the mirror. Again we repeat. Now the image, that is 2, has moved by half unit in the C axis. So it is called C glide perpendicular to A. When it moves along B, so we show this as a mirror. The movement is as this. B, C. Here it is in the B axis perpendicular to A. So B glide perpendicular to A axis. When it moves both in B and C direction, that is diagonally. So this can be considered, it moves this way or this way. Or it moves this way and this way. So it is moved diagonally. Black moves in C and B. Pink moves in B and C. Green shows the diagonal movement, that is B by 2 plus C by 2 is equal to B plus C by 2 perpendicular to A axis. It is called diagonal glide, that is N perpendicular to A. Similarly, perpendicular to B and C axis, one can write the glide planes or glide symmetry operation. So A glide perpendicular to B, A glide perpendicular to C, N glide perpendicular to C glide perpendicular to B, N glide perpendicular to B. Here A plus C by 2, here A by 2, here C by 2. A glide perpendicular to C, B glide we have to remember same glide perpendicular to G, same axis is not permitted. Therefore, A glide perpendicular to A, B glide perpendicular to B, C glide perpendicular to C, it shows the image is moving perpendicular to the plane of refraction. That is, the image can move only parallel to the plane of reflection. These screw and glide symmetries are not permitted in the point groups. Either crystallographic or spectroscopic point groups. In spectroscopic point groups, it deals within the molecule, while in crystallography the point groups operating between the molecule. Next we will go to space group. Triclinic, we have seen 1 and 1 bar, only 2 point groups. We know that A is not equal to B is not equal to C, alpha is not equal to beta is not equal to gamma is not equal to 90. No axis is perpendicular, so no two-fold no rotation symmetry and reflection symmetry. In triclinic, only primitive lattice is the smallest or reduced volume. So only P is allowed. C-centered, F-centered, I-centered can be converted or reduced to primitive in triclinic because the angles alpha, beta, gamma not equal to 90 gives the freedom, and A not equal to B not equal to C also allows. Now we will consider triclinic. This is the origin. This is my A. This is my B. The convention is the standard stating, standard projection, that is down C axis. Then this becomes gamma. In triclinic, we remember alpha is not equal to beta is not equal to gamma is not equal to 90. So this is not equal to 90. Now when you take this one, I got only 1. This is 1. So in primitive it is P1. This circle can be anywhere in the boundary, or the object is found anywhere in the unit cell. So when we consider A is equal to 1 unit, B is equal to 1 unit, A and B as 1 unit, the position can be written in fraction as x, y, z. So this is x, y, z. And triclinic P1, the unit cell itself is the asymmetric unit. As there is no symmetry operating within the unit cell. Now P1 bar. P1 bar is centrosymmetric. One bar is inversion related. So we divide this into 4. This is the thing. The inversion, center of inversion is operated at the origin. This is A and this is B happen to C. Origin at 0, 0, 0. Inversion is operated 0, 0, 0. So you get this one. It's a enantiomer and a minus sign. When we translate along the a-axis by 1 unit, it comes here. Translate along the b-axis, it comes here. Translate along A and B by 1 unit, it comes here. So one can notice 0, A and B. The 1 of A is the 0 of the next unit cell in A-axis. Similarly, 1 of B is the 0 of the next unit cell in B-axis. So when you take this as we can see that there is an inversion getting generated here. This is the equal. All the 4 corners are equal, and the inversion along A by 2 or B by 2 or here and here is A plus B by 2. So 0 0 1 0 0 1 1 1 all the 4 are one and the same. Similarly, b by 2 and a by 1 b by 2 are same, or a by 2 0, a by 2 b by 1 is the same, a plus b by 2 is different. Therefore 0 0 0, a by 2 b by 2, a plus b by 2, 1 2 3 4, 4 unique inversion center when we consider C as 0. Now let us consider this unit cell. This is the 0 0 0. We will divide this a by 2. Then b by 2 then c by 2. So this is a by 2, b by 2, c by 2. You can write 1 0 0, 0 0 1, 0 1 0. If you consider this way, the plane 0 0 0, 1 0 0, 0 1 0 is the same as 1 0 1, 0 0 1, 1 1 1. That is the top plane and the bottom plane the same. This plane and this plane same. Whereas this front plane face and the back face is same. So we can divide a by 2, b by 2, c by 2, or 1 by 2, 1 by 2, 1 by 2. We end up in 1/8 of the volume. So when we draw that 1/8, zero 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 off 0 0 0 0 off 0 off 0. This is off and this is off, so off off 0. So this is off and this is off, 0 off, and this is a off, a 0, b off, c off. So in different combinations of 0 0 0 and off off off, one can write 8 combination. That is 0 0 0 off off off, off 0 0 0 off off, 0 off 0 off 0 off, 0 0 off 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 0. So these 8 are the unique inversion centers in the triclinic system. So in P1 bar, this is x, y, z. This is x bar, y bar, z bar. There are two asymmetric units in the unit cell. One asymmetric unit consists of x, y, z. The other one x bar, y bar, z bar, net by any one of the 8 unique inversion centers. Now we will go to monoclinic. Remember, A is not equal to B is not equal to C, alpha is equal to gamma is equal to 90, beta is not equal to 90. The B axis is the unique axis or symmetry axis perpendicular to which AC plane is the mirror plane. Now the first one is P2. Again down C axis projection. This is our A and B. The two-fold is operating along the B axis. Now we can see that between this and this there is a two-fold getting generated at A by 2. Okay. Now and we see down the B axis. Remember, C is perpendicular to AB plane or gamma is equal to 90. Here B is perpendicular to AC plane, beta is not equal to 90. The two-fold symmetry parallel to the board is shown like this way or this way. When it is perpendicular, it is shown as this way. So this is a two-fold symmetry. Whichever is here, it comes here. Now the same two-fold is operating here and here and here. Divided. So this can be translated here. So then you can see here and it comes here. There will be one more here. This is getting generated between this and this. A two-fold is here and a two-fold is here. These two are related by a two-fold. Comes here and a two-fold here. So there are 1, 2, 3, 4. 4 unique two-fold operating along the B axis perpendicular to AC plane. Zero, 0. This is my C and A. 0 and C by 2. A by 2, 0. A plus C by 2, 0. Remember, the B axis is the rotation axis. So therefore 0 0 0 c by 2 a by 2 0 a plus c by 2 4 unique two-fold axis. Okay, thank you for your kind attention. We'll continue this in the next class.